Hello and welcome to the Core and Platform Development Update. My name is Balázs. We are here with the platform and the core teams today to give you an update, present you the progress of the past 2 weeks. We are going to start with the platform teams and an overview of the platform team's work. Then we move forward with the core team, and the very end we will have a dedicated Q&A session with your questions that you leave us in the live chat below. So please feel free to raise your questions, give us feedback. Please also consider including the whole context of that question as we are going to get back to those at the very end of this session. So we might need some extra context to fully understand your questions. All right, I'm going to share the presentation, and without further ado, let's go with the platform teams.
Sure, thanks. I'm going to start with a quick overview.
Thank you.
And this is a new format. Generally, instead of just diving right in, we're going to kind of give an overview, a quick overview of what the directions were for the last 2 weeks and who worked basically on what. So we basically worked on 6 big issue. Versioning, that was me and then Igor came in and started reviewing it. State sync, which was mainly done by Dima and Wisdom. Rust SDK, Lukash was on vacation for 1 week, and Evgeny as well. So they both participated only 1 week into this. The Rust SDK is more of a client feature, but since a lot of the work is being kind of finished on the platform side, we needed this is actually quite useful for the mobile team. So we're helping out on that side. Then we worked on continuous integration and continuous deployment. These are kind of improvements, and they really speed up the process. We have Ivan and Strophy to thank for those. We've had a lot of work on V24 maintenance and a lot of global fixes, and masternode voting done by Anton. Now, this is not like the sum of all work. These are mostly the directions, and then we're going to get into smaller topics. You're going to see like some stuff that we've done that wouldn't fit in any of these categories, but these are pretty much the big categories that we went down. So who starts?
Right. Well, let's kick it off with Javid.
Sure.
Javid.
Hello, everyone. Nice to have you here. So this sprint, there are few features we've been working on. So first of them is implementation of the ABC errors and error codes that we had previously defined in JavaScript code and being imported to the Rust. However, this work was a bit generalized, and after discussion, we decided to do it with a more granular way. And but this sprint, we've switched focus to Rust SDK or light client, and this work kind of like stopped for some time. So that's why I will focus more on Rust SDK and Rust light client, as we call them. So as this is being developed, and so the main idea was to kind of incorporate some descriptive meta language to describe the data that being operated by this client, and to kind of encapsulate the whole logic inside of the client, and like ease out the work from the users of this client and move it inside of this like client execution with verification. So the clients just send some requests and receive some response with the data, and do not think about other stuff that's happening under the rug. And to do so, we've had to implement a few things. Some of those are like adding additional data to the response. So we've added some data to proof itself, like block ID hash, quorum type, and we've updated the response metadata to include chain ID. This is done to be able to verify signature as part of the proof verification and hide it under the rug of the client, so client users does not bother about that. The next one was to change time resolution. However, since platform operates mostly with milliseconds, so the tender dash guys are actually rounded up the nanoseconds which they operate inside of the tender dash to milliseconds in the block time. This done to keep the consistency within the platform. Also, the drives the light client actually now does the proof verification and receives the data from the proof under the hood. And this is being done right now. The code for it is actually implemented. We're now at the phase of doing unit testing. And there are UniFFI bindings for different languages for this light client being implemented. And currently the build actually builds Swift, Python, and Kotlin bindings. So, which is pretty neat to have. And I think this is it about the REST SDK part that I could explain. Who should go next?
That's me. Thank you, Joey. All right. So for the next bullet point about CI/CD caching, I'm actually serving as a messenger here because Ivan is absent today, and this work was mostly covered by Strophy and Ivan. So over the course of this year, as platform code has been gradually migrated to Rust, we encountered slowdowns when running CI tests and multi-arch releases on infrastructure hosted by GitHub Actions. To address this issue, we moved our runners to more powerful, but also more expensive AWS infrastructure. However, the release builds were still quite slow due to the need to compile all binaries each time. And simple caching actions were insufficient for our needs. To address this, we implemented an S3 cache backend for 3 key components of the build. It's a Docker layer cache to skip building open change steps of the build, and 2 Docker cache mounts for the Rust cargo compilation system and for the node bindings unplugged territory. All 3 caches support x86, ARM, and WASM building targets, conditionally loading cache data into the build runner as necessary for each build step. We enabled high-speed NVMe SSDs in the runners and massively parallel copy operation using a tool called S5CNV for a further 3 times speed up when populating the caches. This required coordination across platform, infrastructure, and action repositories. So as a result, we now have an industry-leading solution that has been used as a reference by several other developers in GitHub. Also, it was to mention that there is expensive commercial solution called depot.dev that sells this solution to customers, and yeah, now we have similar things built in house. So as a result, we were able to reduce build time for a multi-arch release from almost 1.5 hours with the uncached AWS solution to under 20 minutes with a cold cache and just 2-3 minutes with the warm cache, resulting in significant savings and faster turnaround for developers as they test and release the code. So yeah, special thanks to Lukasz and Ivan for the assistance in this work. And yeah, good job, guys. Very impressive, and it will be very good assistance in our day-to-day development process. Let's move on to the next slide. Yeah, so first two bullet points in this slide about the asset lock transactions. They are currently blocked, and we are all waiting for the versioning to be done to proceed with that. I think during the last sprint review, I reported that Dashmate library is actually done, and SDK part is also done, and asset lock validation on the RS Drive PDCI side is in progress. Also, this sprint we worked on addressing issues with the building of X11 hashing library for WASM targets. We have a following setup. We are using X11C code from the Dash core, wrapped with the Rust bindings, and then these Rust bindings are building for different targets, for mobile, for example, for ARM64 and for WASM. And there were some problems building WASM for WASM, caused by absence of the C standard library. So we fixed that, and Dash core is now fully operational for WASM targets. This is it from my side, and thank you. I'm handing this over to Anton.
Anton, yeah, thank you.
Hello, everybody. Anton's here, and today I'm going to give you a quick update on the new features that we have that we are working on in platform. First of all is proof of concept for masternode voting. As I've already talked about it before, but I will go over it once more time. We will need for some contracts, we will need a feature that will allow masternodes to vote on some documents. That is going to be particularly useful for registering usernames on the very early stages of platform, because for high value usernames, we want masternodes to be voting on who those names are going to go to. For example, if I'm going to register a username Anton, which I guess probably some other people will try to register too, masternodes can vote to give that name to me. And that is going to be enabled for very first iteration of name registration. And then we go into disable it. Well, not going to disable it, but there will be a period baked into the protocol where voting will be mandatory. And if vote didn't conclude in this period on a certain names, those names will go to a person who actually were trying to register a name. And then after this period, you will be able to register just any name that haven't been registered in the first phase. So this is being worked on right now. And I'm adding some finishing touches to it right now. Then for fetching data contract versions endpoint and quorum low health, we had a lot of back and forth in the previous weeks about different small things and what should be done. And in particularly for fetch data contracts, we had a couple of discussions with Ivan about how we actually want to present this functionality in the SDK, so it is the most useful for the users. And by the end of those discussions, we decided to do this in 2 phases. And this task that's on the slide right now is referring to the first phase where we built the backend for this, DAPI methods, simple SDK get history methods, the base functionality. And we've decided that we're going to do that right now. And we have a plan now on how to extend this functionality in the future with new methods in SDK. right now, SDK can only just list the history of a data contract one by one. You send a request for data contract history. You can set limit, offset, and you can just paginate through the history, and you will get the date where the change have been made and the version of the data contract at that date. This is great, but we also want to give our users a little bit more flexibility in how they can use it. We want to be able to list the amount of changes that has been made, like the list, without returning the data contracts themselves. We also want to give users the ability to fetch a data contract not only by date, but also by the revision. And we have some plans on some other helpful methods in SDK, but that is going to be an extension now instead of being baked in the first implementation. And those are most likely going to be, this work is most likely going to be done only on the SDK side using the API methods that we've done in the previous weeks. Then we had a little bit of back and forth on how do we deal with quorums when we're rotating when the quorum have low health, and those conversations are resolved as well. So that's all the updates from me on this side. And the next slide, please.
Dima, would you?
Yeah, it's fine.
So, thank you.
Hello, everyone. Well, the first one, the new version of Dash current platform blocked until a version will be done and merged finally in our master kind of the current version of platform, because otherwise SAM should be supported by our changes, and we decided to postpone until the version will be done. So this is the first announcement, and along with this, I want to say thank you for Igor, because Igor fixes one kind of minor issue with the excellent hash library in Rust. So next one, investigate CPU usage in TenderDash. Some time ago, we got a request from our infra team about that the TenderDash consumes a lot of CPU on a testnet. And we started to investigate it and figured out that our build had enabled feature for deadlock detection. So we disabled that feature, and everything started working as expected without a lot of loading. Reduce CPU load probably in 20%. And next one is state sync. Currently, we're working on state synchronization implementation, and we partially done. First of all, we supported this on the TenderDash side, because a new approach of state synchronization is not compatible with the solution which provided by Tendermint initially. So, and we had to slightly modify it in order to be compatible with the Grove DB. So, and the first milestone already done. We supported this behavior on a TenderDash side and started to work on the implementation on platform side, because on the platform we have an APCI application. We should also implement all methods which interact with the TenderDash, like a list snapshots, which is open for review. And along with this, we also supported the creation of snapshot every end block, and is hard-coded value currently in platform. Probably we'll move it in the configuration, but every 1,000 block we create a snapshot. The snapshot is just copy of, like a dump or copy of our state of GroveDB, which we can use for fast synchronization in our network. Well, this is pretty much it from my side. Wisdom, probably next.
Before
Hey guys.
before you go, Wisdom, I'm just going to quickly explain what state sync is to people who don't really know, if that's okay. So state sync, a lot of people here are probably Masternode owners, and as a Masternode owner, you've probably had to resync the blockchain from time to time. And as many people are aware, it takes about 2.5 hours, 3 hours on somewhat fast machines. It could take much longer on much slower machines. And that's with a block time of 2.5 seconds. The Tender Dash is going to have a block time much lower than that, probably around 5 seconds. So we're going to have a lot of blocks, a lot of blocks. To resynchronize this just using blocks would take a very, very long time, even after like a month or 2 months, especially that those blocks are probably going to contain a lot more information. And on top of that, you know, a lot of our nodes are not going to actually contain all full block information. Instead, they'll be pruned. It's kind of a different system than Core. So the way that we sync the whole state is that the state is actually contained inside of GroveDB in the state tree, and we just replicate the data at a certain point X, and we distribute that kind of how like a torrent works. When you download a torrent movie, you're going to download like one part from one node, another part from another node, another part from, you know, like from many different P2P locations, and you're eventually going to get your movie or in a legal movie, by the way, very legal. Something that is in the public domain, obviously. So when you, the same thing kind of applies to state sync. You will get different parts of information from many different platform nodes, Evo nodes, and then you can recreate the state without like hammering one node. In a very P2P fashion, and it's actually should be quite quick. And with that, yeah, please continue, Wisdom.
Yeah, thank you. So currently, GroveDB already has a method for replication, but it's in the context of just 2 nodes. So you have one node that has the state, and you have another node that wants to replicate the state. So it's a direct relationship between those 2 nodes, and then you perform the replication process. But then actual state sync, we are going to be connecting to multiple nodes that have the states that we care about. And then we're going to be getting random chunks from each of these nodes in order to make replication way faster. So that is the work that we're currently doing on the GroveDB end. We're trying to make GroveDB replication compatible with this specification. And hopefully next sprint review, we would have a demo to show this process.
Yeah, thanks,
Thank you very
Wisdom.
much.
Another thing about state sync, we were originally planning on doing it post our first version to mainnet, but the reality is while people are blocked while I'm working on versioning, it's valuable that they get this done. So let's continue on. I believe it's versioning next, right? Or maybe
we have some other tasks that Anton and Javid will talk about.
Oh, yes.
Anton?
Yep. So we have a bit of an issue with the CI audit workflow, which we fixed. So we use gRPC for the communication between SDK and the network. And Google haven't updated their implementation of the JS version of the gRPC for quite a long time now. And that caused a security check that we have a very old dependency to fail in our CI. Unfortunately, even after manually resolving the issue, the audit still was failing because for some reason on the version of Yarn we had in the project, this audit still wasn't passing. So we've updated Yarn version of the project, and now the issue is gone. Now, the second one, the configure network interface in Dashmate, is about a feature for the Dashmate that allows people on the mainnet to run multiple masternodes on the same machine. This functionality wasn't available before because there was no way to pass configuration for the network interface you will run your node on, and the IP ports and stuff like that was just hard-coded into the Dashmate. Not hard-coded, but there was no way to change default values and to run the second node with different network values for mainnet. Now, this works for masternode groups on local networks, but that was an exception. So this feature makes it possible to run multiple masternodes on mainnet with Dashmate running on the same physical server. And with that, I give a word to Javid.
Thank you. We've previously implemented some end-to-end tests in Dashmate project. However, during a few recent runs and during extensive testing of, testing environment for Dashmate, we figured out that they're not very stable per se, and we're now working on stabilizing them. So there are a couple of issues, few minor, I believe already solved, and a few minor bugs. And the major part of those issues are we need to configure, make Dashmate helper to be built all the time we run those tests. And for that to work, we did a slight rework in the way Dashmate builds different services. The code is actually done, and we're now experiencing some strange issues on Linux environment with ports, which we haven't figured out yet since we were busy with Rust Lite client. But I believe already working on it as far as I remember. So that's a quick update on that. Who's next?
Sam, would you continue with the rest of the platform work?
Yes. So this time, for the last few weeks, I put versioning all in one bucket. I'm really going to, because I'm still not done, I want to explain to people why I'm not done, and like how much actual work is going on. Currently, we're at about, I know things shouldn't be measured in lines of code, but the PR is at 52,000 lines of code, that on top of another 10,000 lines that was already merged. So it's big. So in dry versioning, we got a lot done in the last sprint. The thing is, last time I had said we had documented 100%, contracted 100%, and identity at 50%. So identity is now at 100%. All these operations have been done. I think last time the only one that had already been done, but I'm not completely sure, was Grove operations already were done in all of this list. And now that's at 100%, and the verification is also at 100%. I actually went through dry versioning file by file to see if there's anything left to do, and I realized that I had forgotten to do query versioning, I just want it to be thorough. And yeah, so I added it to this list. Then I'm putting the integration work at 25%. Theoretically, there's nothing that needs to happen, but that never happens. There's always going to be something glitching, something wrong. So I'm putting, that there's still a lot of integration. Now, it's already integrated, right, with Drive, ABCI, and every place. But something's going to go wrong. So I don't want to say like, oh, we're done with Drive versioning. Something's going to happen, and that probably will require some work. But that's, Drive versioning is in a very good state. Now, moving on to Drive ABCI versioning. Drive ABCI versioning is pretty much, can we go to the next slide for Drive ABCI versioning? Or
something is not working.
Oh,
too much. Yes, all at once.
oh, now we're in. Oh, there we go. Yeah, there we go. So ABCI versioning. ABCI versioning is, we call it Drive ABCI, and that's the main application. It's pretty much that runs the execution. I've already said this many times, but for people that are new, it runs the execution. It does like the initialization, the block begin, block end, all the different aspects of block execution, checking transactions, all of that stuff. Now, ABCI versioning was already almost done. There's nothing that really happened in the last 2 weeks here, except I fixed a lot of bugs related to Drive integration, right? So like that has gone up, but still the amount of work left here is minimal. The amount of work left in Drive as well is minimal. The big stuff left, the reason why I'm still not done was, next slide.
Did I went to
DPP versioning? Yeah, so like there were some things that I moved from Drive to DPP because they actually, there was actually a to-do in Drive when I saw it as I was doing versioning. This should be moved to DPP. DPP is kind of like the place where all of our structures should live and all of the validation logic. And if there was some high-level validation object in the wrong project, there would be problems in the future. So I just decided to move it over. It's now in the right position. And I also versioned it. So for balances and for block, I'm not sure why I said that balances are, oh yes, balances are at 80% because they have hooks all throughout the system, like for refunds, for credits, for everything. And a lot of that code just needs to be updated to the right position in the code. Nothing really has changed logic-wise. It's just like, since it's probably being called in 300 places in the code, I just have to, verify that everything, all the dependencies are working properly. So when we go to data contract actually slowed me down a lot in the last 2 weeks, and it was because of the actual complexity. Data contract has 4 different types of versions when you actually think about it. We have the user-based version. So basically, like when a user wants to update the data contract from one version to another. We have the data structure version. The data structure version is the actual validation and indexing and all the stuff that a data contract does in structure. Then we have the serialization of the data contract. For example, when you store the data contract on disk, that has a version. And there's one more version. I keep on always forgetting the 4th one. I guess it must be the methods of the data contract itself that need to each be versioned. So I got most of that done. the real tricky part was disassociating the code structure version and the serialization version. So for example, when we change the code structure, we probably don't want to change the serialization. And we also have to remember that data contracts are stored on disk. And for example, if we're on version 15 of the structure of the data contract, not the actual structure of the fields of a data contract, but the structure of the code representing the data representing the execution of a data contract. We have to, it probably will still be able to be taken from the serialization one. Anyways, it was hard. It's done now, or very close to being done. I figured it all out, and I built that system in. Now, for documents, I also did that, but I had done some versioning, and I thought I kind of had been done with a lot of the part of documents, but then I realized that I would like to use the same way that I used for data contracts to serialize and store documents. So having the serialization version disassociated from the code structure version. Yeah. Then we have state transitions, and state transitions, the versioning I had done a versioning scheme of state transitions before 2 weeks ago, but I realized that I didn't completely like that scheme. So instead I moved to a new scheme for versioning, and it works a lot better. I also moved all the state transitions into one location in the code. I split out, so we had like these massive files for state transitions, and I split it out into like many files. So the code looks a lot cleaner. It was also kind of needed because getting everything versioned, and also you kind of need cleaner code. So that's in a pretty good state now. There's just a little bit of work left for document transitions. I checked earlier. But you know, document transitions are not, that's pretty much just one. We have like 5 identity transitions and 2 data contract transitions and 1 document transition. So yeah, it's not a whole lot, and I've already done a lot of the work on the document transitions. And then we have validation. Validation, so there's been a lot of versioning of the validation in DPP, but it's still not done. So, you know, I really was hoping that we would be done with versioning by this sprint and I'd be able to show everybody, but, you know, it takes time. So I apologize, and I'm continuing to work faster, as fast as I can, at least, on this to get it out. With that, let me go on to some other news. The deployment update of deployment 9 still flawlessly after 6 weeks. We kept on running it. We keep on running some tests against it. There's really no problem. What we're going to do, and Cora will mention this soon, is we're actually going to, we haven't touched this in quite some time, but we're going to actually update it now with V20 very soon, and Cora will give a bigger update on that. Right now it's running a very alpha version of V20, and we have done a lot on V20 in the last month and a half, so we're going to update that. Okay, so then we can talk about what's left to do for beta 2. So this is kind of the same slide as usual. As we heard today, versioning, big, annoying stuff. Then we have another one that's getting along, which is the mass node voting that Anton worked on pretty exclusively, or close to exclusively, for the last 2 weeks. And then we have the state sync that has also been worked on a lot. So it's actually going okay-ish in the sense that, well, yes. Versioning is blocking a lot, and as soon as versioning gets done, we're going to be able to merge everything in, and things will go faster. So I'm just very hopeful that we'll finish with that quite soon. Okay. Yes. So with that, let's give a nice, really a round of applause for a surprise from Paul from research.
Woo!
Hey, Paul, come on, show us what you got.
Let's go. Hello, everybody. I am going to be sharing something I've been working on for the past few weeks. Let me see, share window. Okay, so this is the kind of pre-announcement demo of the Dash data contract creator. This is a web app written in Rust, and we have we have a design for it. This is kind of like my terrible
Paul?
Design. Yeah.
Has anybody I don't think anybody can see your screen.
Yeah, Paul has started screen sharing, but it's still stuck in that state. Can you just reshare?
Sure. Can you see?
Not yet. Let's wait a couple of seconds. We actually tested this right before the development update, and
Yeah.
Sam, you mentioned that it took you for a while to get the results from the screen sharing. Is that right?
Well, actually, I noticed that things were laggy. I thought it was my own internet connection.
Yeah, I thought that as well.
Oh, there we go.
Here we go. Yeah, see?
Okay.
Yes.
All right, great. Okay, yeah, so this is a Rust app that I've been working on for the past few weeks. And this is kind of just, I'm not a front end designer or anything, but we have Ross from our graphics designer made a nice design for it, so it'll look nice. We just have to integrate it into the app, but it is fully functional now. So you can go to dashpay.io and use this. As you can guess from the name, it's a data contract creator. And we will probably have the design uploaded within probably about a week is our estimate. And at that time, we'll announce it on Twitter and stuff. So yeah, it's data contract creator, and it has a chat GPT widget. So if you have a OpenAI API key, which you can easily just go to their website and get, you can paste it up here and describe the app that you want to make or deploy on Dash platform, and it will generate a data contract for it. So yeah, I'll do that. I will type, I've done this prompt 100 times at least for testing, so it should work pretty good. NFT marketplace. And so now we're just waiting for a response from OpenAI. And when we get a response, it will populate this window on the right, as well as the form on the left. So you don't have to use ChatGPT you can just fill out the form, and at the bottom click submit, and your contract will be populated in the right-hand field over here. And we also have DPP validation. So it checks basically if your contract is valid against Dash Platform Protocol. And it's a nice way to test your contract without actually submitting it to platform. So you can save some money doing that.
Does it normally take this long?
Sometimes this is a little bit longer than usual, longer than average.
That's normal. That's the demo thing. Whenever you're on a demo, it will take long. By the way, I just would like to add that this is a front end website, meaning that we don't like if you put your OpenAI key in the top, we don't like DCG does not have access to that in any shape or form, correct?
Correct, yeah. We have it's an open source app, of course. You can go on the Dashpay org on GitHub and see the repo. Can you guys see, has it populated?
Yep, perfect.
Okay, cool. Yeah, so DPP validation passing. Let's see what it made. We have a document type called NFT and properties, token ID, token name, token description, image URL, image hash, and so on, properties about the NFT that is supposedly going to be available on this marketplace. And of course, various like validation constraints, like the max length of the token name is 64 characters. Properties, it created some indexes. I found that we can tune basically how ChatGPT works with this app, but the latest tuning doesn't do the best job with indexes, but it does do a good job at making comprehensive properties. So we can try to play around with that. But I'll move on to that next. So we have NFT, an order document type. So I'm assuming like, yeah, if you want to buy or bid on an NFT or something, I'm assuming that's what it's trying to do. Token name, token price, owner, buyer, etc. Indexes, and yeah, so that's like it's at least a pretty good starter template for a data contract for an NFT marketplace on Dash platform. And so you can make changes to it. If you want to use the form on the left, you can remove properties, rename them, whatever. And you can also use GPT. I will say, make more indexes for NFT document type. While we're waiting, one other cool feature is the import button. So you can import existing data contracts as well and edit them. So yeah, right now this is just a data contract creator, but in the future we have plans to basically allow you to, Sam suggested that basically this will generate like QR codes, and you can just scan the QR code with your phone and register the data contract through the Dashpay app. So we'll make it easy to register your data contracts that you create with this app on platform. Okay, great. So we have a bunch of validation errors. Order document has more than 3 unique indexes. So we can go down to order indexes, way down here. And let's see, 1 unique index, 2, 3, 4, 5. So let's just uncheck those 2 to make it 3. Submit.
What's funny though is that you just found that it can have more than 3 unique indexes. I did not even know that. That's actually we can have unlimited unique indexes. We'll have to look into that one. That's probably like an old limitation that has just stuck around somehow. Oh, but it's probably not in V25 anyways. This is against V24, right?
Yeah.
Yeah, so yeah.
Okay. Yeah, so let's see. For all of these indexes that I added, you have to change. I don't know why it always sets max length to 64, but you have to change these to 63. Yeah.
Yeah, work in progress, right? We'll get it fine-tuned properly eventually.
Yeah. A big part of it is really fine-tuning, like basically this, I like prepended a prompt to the user input. And basically I'm just trying to fine tune that to make it produce a good data contract. So yeah, that's it. Again, it's dashpay.io.
Wonderful. Well done, Paul.
Thank you.
Well done.
Oh, actually,
One more thing.
for now, if you want to register the data contract, you can just copy the contract from here and go to the SDK on dashplatform.readme.io, and you can just paste it into this register data contract tutorial code. That is until we add QR codes or whatever we're going to do. Okay, that's all.
Yeah.
All right.
So
Thank you very much.
hopefully in 2 weeks, you're going to see Paul again with QR codes and other stuff.
We'll see.
and in a later time zone.
All righty. Are we ready to move forward with the core team?
Sounds good to me. Let's move on to the next slide. So on the 6th of this month, so about a week ago now, a little less than a week ago, v19.2 successfully activated. And so now you can see virtually all of the Masternode network is now on 19.2. Anyone older than 19.2 is getting banned, and they're not really able to stay synced, so they're getting banned. During the v19.2 activation, a small number of masternodes had some issues and crashed. They were able to just restart and recover from those issues. There was nothing too problematic, and then that issue repaired itself as new quorums formed. It was likely that there was a couple of keys that were valid under the old system but were invalid under the new system, and so in some instances we ended up getting a couple of crashes, but it didn't affect that many users. And like I said, it repaired itself as new quorums formed. And now we're at a point where 15 EVA nodes have been registered and are existing on the network. And yeah, no issues with v19.2 activation really, or no issues at this point. Like I said, there was that one small issue, but it repaired itself and we are good moving forward. All right, let's go to the next slide. Alrighty, so we made decent progress on our v20 work, and we are planning to do a updated DevNet release sometime this week in the very imminent future. That will update the DevNet that Sam was talking about earlier to a much newer version of v20, and that version will include asset locks and the decentralized randomness beacon. It might include the masternode reward location reallocation, and it probably won't quite include the enhanced hard forking yet, but that will be a very nice kind of bump. And there have been a lot of changes in the past month or so since the last proper core version that has been pushed out to a DevNet with platform. So we're excited to get asset locks out there and start testing against asset locks properly, and start testing against decentralized randomness on a DevNet, and move forward with V20 development. We're expecting to do a testnet release in somewhere around next week. That might change a little bit. We'll see what happens. But hopefully, at least by the time of the next sprint review, we will have a version of V20 out onto testnet. It seems likely at this point that we're going to hard fork testnet multiple times during the V20 testing kind of procedure. And as we move closer to a final mainnet release, we want to make sure that we are deploying to testnet to ensure that we're continually kind of releasing versions of platform and continually testing against newer versions of core. So the plan is we'll have an initial hard fork that will enable asset locks and decentralized randomness. And then in the future, we will have a hard fork that is done via the enhanced hard fork implementation. Once EHF is done, we'll deploy a new version of core, and probably that version shouldn't require any kind of platform wipes or anything like that, but we'll speak more to that in the future. And then we will probably do a relatively deep reorganization and re-hard fork testnet going from V19 to the final version of V20, so that we make sure we have a proper a test that is comparable to what mainnet will see. And so in total, we'll probably end up having 3 hard forks on testnet. The first hard fork, like I said, enabling asset locks and decentralized randomness. The second hard fork testing EHF. And then the third hard fork testing going from a pure V19 to a pure V20. We got a lot of work done in the past 2 weeks. You can look at the list of PRs there. It's a lot of refactoring, a lot of kind of low-level stuff that I don't think makes a whole heck of a lot of sense to go into a lot of detail about. But if you're interested, always feel free to go over and look at GitHub. Yeah, I think we're good to move on to questions, Balázs.
Alrighty, then move on to the questions. So I'm going from top to bottom, skipping some questions like shout out box, the next Twitter. Obviously, yes. So data contract versions with like a Git?
No. Data contracts can't be like Gits. Not really. So the way Git works, well, I'm not going to explain how Git works, but Git just makes small changes and puts them, the diffs of 2 versions, just one after the other, kind of. And then when you want to get a Git repository, you get the whole repository. Platform for a data contract actually doesn't work with diffs. You just get the latest data contract, and there's going to be many data contracts before, but if you're doing data contract versioning and you're keeping all the versions, you actually have to pay for every single version, the full amount for every single version that you put in. Now, that's not a very high price, honestly. Yeah, maybe you're going to have to pay 5-10 cents to register a new data contract, but if you, well, could be more, but depending on your data contract size. But yeah, it's not as efficient as Git, because it's also when you're also trying to make it efficient for the clients that are trying to get the versions, and Git is not efficient for getting a specific version in a decentralized way. So maybe more in depth
Thank
explanation.
you very much. Why not do versioning after the release?
Yeah, that is a good question. So the basic problem with doing versioning after the release is that you can't actually go back in the past if you made a problem. And since the past is not versioned, it's really hard to upgrade and to find a way to upgrade. So really, if we had done versioning before the release, we would have had to think of all possible situations where versioning can go wrong and had to actually figure out if we covered all of them and done a hack, kind of like a hack solution for all of them. Now, we would have probably missed a few things because it's impossible to really know such a complex topic before actually doing it, in my opinion. And missing a few things would have been very painful going forward. There would have also, yeah, I mean, that's the main reason. Yeah, the other thing is just putting hacks all over your code to support versioning in the future. It's basically giving a debt. You have like a very bad debt that you have to pay off at some point. It was considered, but I honestly thought that it would just take longer because you really have to think of everything, and it would have been very hard to do.
Thank you very much. This is the first time we've seen Paul on screen. No, this is not the first time we've seen him 2 weeks ago as well. And we hope we will see him a lot more in the future. All right, you answer the idea or question that import data contract from platform. What's the status of Bitcoin backports? Pastor, if you can speak to that.
Yeah, so Bitcoin backports is something that we're really always working on. And so I don't really speak to it a lot unless there's something kind of really interesting from like a user perspective. One of the more interesting things that we're working on is backporting the Assume UTXO project, which is actually similar to a feature that Sam talked about earlier for platform, but just for core, where you won't necessarily have to reindex. You could use a trusted UTXO snapshot and just continue from a certain block height. In that situation, you are trusting that snapshot. If that snapshot is kind of corrupted or malicious, you could have issues later on. And yeah, so you don't necessarily always want to do that, but for a lot of people, it could be a very useful tool to say, okay, I trust this person. It's very unlikely that, you know, everyone here is lying or something. And so instead of reindexing and taking, you know, multiple days on my cheap Raspberry Pi or something, I'm just going to use a UTXO snapshot and get up to date. So once that project is complete and we have that, that's something that, you know, obviously I'll mention here because that's a very kind of cool feature and something very cool. But the vast majority of the backports are just kind of simple refactorings and small bug fixes and stuff like that. Anyhow, I responded.
Maybe Ryan referred to that we had this table previously.
Yeah,
I think we showed that the status, what's the percentage of for each version.
Yeah, I'm getting there. I'm just
okay, so
long-winded. Anyhow, that table comes from a spreadsheet that we maintain. That spreadsheet is linked to in the GitHub issue 4000. And so you can always find that spreadsheet and see what the current status is. I didn't include a kind of screenshot of that right now. But roughly version 20 is at about 85-90%. Version 21 is about 52%. Version 22 is about 30%. Version 23 is about 15%. But you can take a look at that spreadsheet and see the exact figures and see exactly what backports have been merged and have not been merged. Yeah, I think that's a good response to that.
Thank you very much. So when I give it to Sam. If you would give us a summary, how hopeful you are from 1 to 10, how optimistic you see the future.
Yes,
I
yes.
know you
yes.
went through the items on the what's left side, but just a general
If we can get
idea.
versioning done, if we can get versioning done, everything is going to be smooth sailing, because like it's the big last thing, the biggest last thing. Then there's going to be a lot of small things, and like state sync is being worked on. State sync will probably be close to completion with when versioning is done, or somewhat close. We're going to have masternode voting probably also in a good state by the time versioning is done. But you know, then there's going to be bugs. There's going to be some more code to fix, to write. But yeah.
Waiting for the bugs.
Oh yeah, waiting for the bugs. But I mean, it's probably not even. I mean, at that point, I'm hopeful that people are going to tell us our bugs. Right? It's going to be out on testnet, and we're going to have people, you know, saying, "Hey, bug here, bug there." I mean, that's a good state to be in, honestly. And we'll be fixing things as soon as we can. I mean, as quickly as possible.
Thank you very much.
Yeah, so just look out for versioning v3 PR to be merged in. Really going as fast as I can.
Thank you. When will Spork 23 quorum proof of service be enabled by DCG, and why does the Dash Core wallet still show unknown new rules activated version bit 8 now with V19 is fully activated?
Yeah, so on the first point, we could enable Spork 23 at any kind of moment. It doesn't change a lot because version 19 non-19.2 is stalled, and so they're getting banned anyway because they're not able to participate. That proof of service Spork only works to ban people with a old protocol version. And in the bump to 19.2, we did not bump the protocol version for masternodes. And so enabling that Spork wouldn't have done anything. And even right now, the enabling that Spork really wouldn't change anything. 19.1 nodes are getting banned because they're not able to participate. It probably will be enabled in the near future, but it doesn't really change anything. Then on to the second point.
It passed up.
What's up?
Go on to the second. I'm not completely sure of this, but I think the protocol version did upgrade in 19.2, but just the minimal protocol version still allowed v19.1.
Correct.
Yeah.
Yeah. Okay, on to the second point. Regarding the unknown new rules activated, I need to play around with it a little bit more. It makes sense to me why it still shows up, because basically, if you kind of look at the history, it looks like we activated bit 8 twice, which kind of we did. And so it's looking at that first time, and the software is saying, we didn't actually change anything. We didn't have a hard fork configured for the first time that we activated these bits because we ended up delaying that hard fork. And so the software is confused about that first time that we got activated. Okay, yeah, my local nodes are also showing it. Well, one of them isn't. So I'm not sure if there's something a little bit weird where if you reindex, it might not show up anymore or something like that. I need to play around with it a little bit more and kind of figure that out. But it is probably a bug that we want to fix in a 19.3 or something like that. But it doesn't really, it's just a little annoying. It doesn't affect anything. It's not a problem that it's showing up, but it is kind of just a unnecessary warning that in the general case is good, but in this case, we probably want to add an exemption or something like that and get rid of it.
Thank you very much. So last question, Pasta. Can you tell us more about the decentralized masternode beacon? Can this fulfill the last remaining purpose?
Yeah.
Mining?
So there's a dip for this feature. I'm not positive if it's published. Sam, do you know if this is a published dip or not?
No, I don't know.
Okay. So either it is published or at some point it will be published. But the gist is that right now for we in the creation of a quorum, we take the masternode list and then we randomize it by some key. And then we select the first 50 nodes from that now random list. And that's going to be your quorum. Obviously 50 is just an example. It'll depend on your quorum size. And you select those nodes and you make the quorum from those nodes. Right now, that randomness source is a block hash. Theoretically, it could allow a miner with a metric ton of hash power to gain some kind of advantage and maybe take control of a quorum with a lower percentage of masternodes than what otherwise they could take control of. And basically they would do this by just throwing away blocks after blocks after blocks until they find one where the quorum that will result from that block is one that is kind of beneficial to them. It's kind of a theoretical attack, but having a good source of randomness is important for the security of quorums. But it doesn't necessarily make sense for that to be dependent on mining. And so the randomness beacon is changing that from using a block hash to basically using a previous quorum hash. And that quorum hash is affected by the signatures of the master. Well, of the master.
I think
it's
quorum signature, I think.
Yeah, it's based on a quorum signature on a chain, like of a chain lock, I believe. I would have Odie talk about this because he implemented it, but sadly he's on vacation this week. But basically we use a chain lock or a quorum signature as our source of randomness. And that is what is actually used to derive the next set of quorums. Anything you want to add, Sam?
No, that's a good explanation.
Cool.
There's a lot of caveats, but I don't think anybody's really interested. It's like there are special scenarios, for example, if blocks don't have a chain lock, et cetera, et cetera, et cetera. And they're all going to be in the dip. And so, yeah, this is actually a really cool network upgrade. And when Pasta was talking about miners potentially having an advantage, we're talking about maybe a miner with 99% of the hash power. They could theoretically do some very nasty stuff if they also had, like, let's imagine like 200 or 300 nodes, right? But again, 99% hash power and 200, 300 nodes. It's not master nodes, by the way. It's not like a very big risk right now. But the truth is that, or maybe even more than 200 and 300, it might be like 600. I forget. I think it may be 200, 300 for instance sand, and much more for other attacks. The thing is not so much that we're worried about this. It's more that we want to make 100% sure that, well, it never happens, all right? Or there's not even a theoretical one. On top of that, yeah, we just, like, it's not, it is a nice move forward anyways, because we get just more security from a more random source. And the signatures in BLS are 100% random, like much more random than anything else, provably. So.
All right, our time is up. Last quick question. V25 is tested after versioning. Yes. I mean, DevNet and then testnet.
Yeah, we did think about releasing to testnet before versioning. And I do really want to get something V20, like we could release V25 right well, very soon, like in the next week without versioning. But since versioning changes so much, it might be best and would require a wipe of testnet. It might just be best to wait another week until versioning is done.
All right. So thank you very much. We were about to play an outro, but the guys pointed out that it might be a copyrighted one. So without that, we are all who are in the call going to sing a song for the outro. No, just kidding.
Oh,
thanks, everybody.
Is this how we get more Dash Core funding, huh? I
Exactly.
sing and people pay me to stop.
We are all singing. All right. Thanks for joining for this update. Thanks for the questions and the conversation. See you in 2 weeks and see you in Discord as well. Bye-bye.